Today, I am joined by Bert Beckwith. He is the developer on the Micronaut project. Maybe I'll let you introduce yourself, Bert.
Sure. Yeah, I've been a Java developer for over 20 years. I am currently on the Micronaut team at Oracle Labs, and I was previously spent a lot of years on the Grails team at Spring Source and VMware and Pivotal.
Right, so you have a lot of experience in framework design and development.
Yes.
Okay, so today it's Micronaut's turn. So we're talking about Micronaut and GraalVM. So I'll pass it over to you, and then I will come back at the end and we'll take some questions. Off to you.
Okay, so let's first talk a little bit about the motivation behind the creation of Micronaut. So with traditional architectures, we typically deploy an archive into a container, like a WAR file. That container might have multiple deployments, each with their own class loader plus the system class loader. With newer, more modern architectures, we use technologies typically like Kubernetes and Docker, often in a cloud infrastructure where apps are deployed into small containers where each app is isolated from the rest. And this allows much finer grained control over resources like CPU, memory, disk, network, etc., and results in lower deployment costs. Traditional frameworks like Spring use approaches that negatively impact memory usage, startup time, and et cetera, such as reflection, runtime bytecode generation, runtime proxy generation, and dynamic class loading. These affect deployment and redeployment, especially when working with microservices and serverless, where bloat in frameworks and servers and containers, et cetera, can really compound quickly. Ideally, you want these supporting systems, these containers and frameworks, to be as small and lean as possible. And that makes scaling up to meet surges in demand faster. And these approaches also affect the development process, where slow app startup and slow test running negatively impact the developer experience. And of course, as application size increases, this bloat and startup time also tend to increase. These framework features are great and help a lot with productivity, but there are those hidden costs. And we can disable auto configuration, class path scanning, et cetera, but the work required to replace that would be, significant. And Java itself poses some interesting challenges for framework developers. Reflection is expensive, both in terms of time and memory, and the Java annotation API depends on reflection. Generic type erasure makes it impractical to know the original types, and a lot of framework code has been written to work around this. Runtime proxy generation increases memory usage and slows startup time. Now, multiple frameworks, including Spring, Jackson, Hibernate, et cetera, will cache reflection lookups, but often redundantly cache the same data. And the JDK lazily initializes all reflective data on first access. That includes every field, constructor, method, et cetera. And in large apps, that can be thousands of methods and hundreds of megs of memory. So what is Micronaut? Micronaut is a microservice and serverless focused framework that also has support for command line applications, and even really any application with a static void main method. And it's even used to create Android apps and Swing and JavaFX desktop apps. Micronaut's annotation processor hooks into the compilation process to use annotation data to build framework artifacts at compile time instead of the more traditional runtime processing. Now, doing work at compile time has many benefits. Instead of runtime class path scanning, code is scanned and information like generic types is fully available. Micronaut AOT compilation generates all framework infrastructure, including dependency and configuration injection, annotation metadata, including meta annotations, AOP proxies, and Bean and Pojo introspections. And this is all done without the use of reflection, runtime proxies, or dynamic class loaders. And another significant benefit of doing this work at compile time without runtime reflection and proxies is that apps tend to be a lot easier to debug. Method calls are visible without reflective or proxy calls that are really, really tedious to step through. So what is GraalVM? GraalVM is a high-performance JDK distribution. It increases app throughput, reduces latency, and uses significantly less memory, so your apps run faster and cheaper. It includes the Graal JIT compiler that runs on top of Hotspot and has many optimizations and is written in Java. It also includes the native image AOT compiler, which optimizes away unnecessary code and compiles Java apps into small, self-contained native binaries that are great for cloud deployment. And we'll see this in a bit when we get to the demo. Micronaut and GraalVM work really, really well together and are a match made in heaven. It's simple to configure the native image process because Micronaut doesn't use reflection or runtime proxies or bytecode generation or dynamic class loading. All right, so that's a lot of talk, but let's do a quick demo. So there are a few different ways to create a Micronaut application. One, if you like using the command line, is SDKman, which I highly recommend. It will install Micronaut for you, but it also can install versions of Grails, Groovy, Gradle, and lots of other tools. And it even installs JDKs, including GraalVM. Another option is the starter web app that we have at micronaut.io/launch. Now that allows you to choose the application type and the JDK version, the language, your coordinates, the build tool, your test framework, and then any of many add-on components. And then once you're ready, you can generate the project. I'm going to use IntelliJ, which really is just which has great support for Micronaut. And this wizard is a front end to the Micronaut web app that we were just looking at. So I'm going to use Gradle, but you can use Maven if you like that. I'm going to use Java, Spock, and we use Java 8 because we're not doing anything fancy. And the app is going to be a basic front end to a database using Hibernate and JPA and an in-memory H2 database. So we'll tick the Hibernate JPA box, which gives us Hibernate and JPA support, but we'll also use the Micronaut data JPA, which gives us even more functionality, including repositories and really cool stuff like that. So IntelliJ will wire up the app for us. And just really quickly, we're going to take a quick look at the generated files. So the build script is really short, really simple, because the application plugin does takes care of a lot of the boilerplate for you. So really, for the most part, you just have to configure your dependencies. There's also the main, the application class that has the main method that starts your app for you, and the application YAML that has application configuration. So let's first create a controller so we can have a view into what's going on. So we'll annotate that as @controller to get it wired up into the application context, and we'll set up the URI, the root URI to be demo. And we'll just do a simple hello world endpoint to just make sure everything works. And to get this recognized as an endpoint, we annotate that with get, or we could use post or put or delete or whatever verb you want to use. And we'll make the URI for that one hello. And now we have a complete Micronaut application that we can run, and we can test it inside of either a web browser. If I could type. Or curl. Great. Okay, so let's add a entity class so that we can store data and access data in the database. This will be pretty simple. We'll annotate that as @entity, so it gets wired up. And this is really interesting. This shows the integration between Micronaut and IntelliJ. IntelliJ is telling me that the compiler is complaining that we don't have a primary key, which is great. Let's add that. Simple as that. Now let's configure the ID to be auto-incrementing. And let's add a persistent property, a name property. We'll make that non-null and unique. And let's also add in a not null annotation so that before we even try to go to the database, validation will block that, because we don't want to waste time going to the database only to have it throw an exception saying that we violated a constraint. So let's add a constructor, a convenience constructor with the name and getters and setters. And notice again, the compiler is complaining because I added the non-default constructor. The default constructor isn't generated, but we still need that. So let's add in that default constructor. Great. Okay, so in order to work with the data, we need some sort of way to access the create, read, update, delete standard stuff. So let's create a repository. It's actually going to be an interface because we're not going to write any persistence code. We'll annotate that at repository to get it wired up. And we'll extend an existing Micronaut data JPA interface called CRUD repository. And that takes two generic types, the entity class and the primary key type. And that's it. This is a fully functioning create, read, update repository. By extending this interface, we get all the save, update, delete, find by ID, find all, count methods. And notice this, it's annotated as @ blocking. That's going to come in handy. We're going to reference that later, because this is a good reminder that database access, unless you're using a non-blocking driver, which is unlikely, your access is blocking. So you want to be careful not to block the UI threads, the request threads. All right, so let's create a simple data populator that will insert some data into our database. So we can use that for the testing. We'll make that a singleton so it gets registered as a bean, and we'll implement the application event listener interface, which takes a generic type of the event that we're listening for, application startup event. So when the app starts up, this method will get called and we can do our work. So we'll dependency inject the repository we just created. Using constructor injection. So it's final and can't be changed. And let's insert that data. So we don't want to insert anything if we already have data. Bail early in that case. Otherwise, all right. So there we go. We have pretty much all we need. I'm going to do one quick thing. We're going to change this so that we show SQL and format it. And now when we start up the application, we'll see that all working. Okay, so that started up pretty quickly, and we can see the SQL there for the table creation and the inserts. So that appears to be working. Now let's go back to our controller and add in another endpoint so that we can actually see this data. And we'll do a lookup by ID. So we'll take an ID parameter. And we'll annotate that again as a get, and we'll call that /thing. And we'll add in a URI parameter that's going to get data bound into this parameter here. And in order to do that, we add in the @path variable so that Micronaut does all that data binding for us. It converts this string into a long. And again, we need to dependency inject that repository. And I'm going to go back here real quick because I want to make this transactional so that this either all works or all gets rolled back in case there's a problem. All right, so now all we need to do is just say return thing repository. I call it repository. Okay, not a problem. Find by ID, and notice that that returns an optional. So if it's not found, do an or else null. And this points out something kind of cool. So if it finds it, it'll return the thing, and Micronaut will automatically serialize that as JSON. And we know that because if we step into the controller annotation, the default produces and consumes is JSON. You can override that, but we're going to leave that as it is right now. And as I mentioned before, we don't want to block the request thread. So we're going to annotate this as executing on a different executor. And there's an existing one that's perfect for this, the IO task executor. All righty, so if we run this, the app again starts up very quickly, and we can test this with curl and in a browser. So demo/thing/1 gives us the JSON for the first one, 2 gives us the JSON for the second one, and 5, since there aren't 5 of them, gives us a 404. That's pretty cool stuff. Alrighty, so everything's working. So we are now ready to build a native image. I'm going to run GraalVM classes first for completely unrelated reasons. I want to, while the native image is building, I want to take a look at some of the generated code. So we want to make sure that that's there. And as of Micronaut 2.1 for Gradle users, there's a native image target added. Oh, that's not going to work because I'm not running GraalVM JDK. So let me switch to the GraalVM that I have installed here. And because now I'm running a GraalVM JDK, GraalVM native image will work. This will take a couple minutes. While that's running, and we're not going to spend a lot of time on this because this is not exactly readable code. This is decompiled, compiler generated stuff. So I'm not going to spend a lot of time on this, but I just wanted to give you a little bit deeper dive into what's going on behind the scenes, because we talk a lot about how, Micronaut does everything at compile time and does a lot of work for you, but I want to actually show you some of that work. So for example, up here, these two classes include the AOP advice that will make the data populator transaction. So it will wire up the logic to join an existing transaction if one is available, or start a transaction if otherwise. So that's pretty cool. The demo controller definition class, we can see the cached metadata from all the annotations that we added there. So that's all available at runtime, both to Micronaut and to application developers. In the thing introspection class, all entities are what Micronaut calls introspected. And there's an introspected annotation that you can use to make regular POJOs and introspected. And this is a great way to avoid reflection. So the compiler will pre-compute lookups for properties and constructors and methods and store that for you, so that when you go to run those methods, for example, when you're serializing or deserializing to and from JSON, instead of doing the traditional stuff where you dig through the class and find out what it has so you can know how to convert your properties into JSON, all that information is already available. So no cost, no slowdown. And then one last thing I wanted to look at is the implementation of that interface. So remember that the repository class that we're using, we use the count method and the save all method. So at runtime, at compile time, sorry, not runtime, at compile time, Micronaut builds an implementation of that interface. So this is that class right here. It implements the repository interface and has all these methods to do all that work. And these inner class definitions are those methods. So they can, so this is exists by ID, this is count, this is update. So all those, all the code and all the logic is pre-computed so that everything just works at startup. Okay, so that native image took 2 minutes, 46 seconds. That's pretty quick. And if we look in the build directory, we can see the native image that was created. That's 97 megs or so. And that's executable. So we can deploy this to a cloud. We don't, we can put this in a really minimal container that has next to nothing in it because it's statically compiled and it doesn't require an existing JDK or anything, because all the stuff that the JDK would typically provide for you is built right into the application. So build native image application. So that starts up in 1 second, but we can do better. 63 milliseconds, 62 milliseconds, 63 milliseconds. Man, that is just crazy fast. And it's doing all the same stuff that the regular non-native image, the standard stuff, was doing. It does creates a database, it builds up the application context, wires up your controllers, all that in about the time that it would take to run a batch file. This is, I'm still like a kid in a candy store with this stuff. I think it's so cool. Okay, so that's the demo. That's all I had for that. So we have some more information available, of course. Please go to the Oracle GraalVM homepage where you can get lots of information about Graal, and connect with us on Twitter, and please contact us if you have any questions.